That night, there were no explosions or dramatic announcements, just two silent images that the moment they appeared on astronomers' screens, changed the direction of the scientific conversation. On November 9th, the James Webb Space Telescope and the Virtual Telescope Project released new observations of the interstellar object known as 3I Atlas. And what appeared in those images was not merely unexpected. It was deeply disturbing. 3I Atlas appeared as a compact, intense, perfectly defined point of light. No tail extended behind it. No cloud of dust, no trace of gas, no sign of material being released. Nothing that would be expected from a body crossing the inner region of the solar system, where the sun's heat normally turns ice into vapor and creates long tails visible from vast distances. The most unsettling aspect came from the comparison with earlier records. The object looked exactly the same as in the images captured in July by the Hubble Space Telescope. Same shape, same brightness, no visible alteration. That alone would already be strange. But for an object that, according to the models, should have lost more than 5 billion tons of mass due to solar heating, this unchanged appearance represents a direct challenge to the known laws of cometary physics. Some scientists treat the case as an extreme anomaly. Others see something deeper. Harvard astrophysicist Avi Loeb described the phenomenon as a possible warning from the cosmos. But before we go any further, don't forget to like the video and subscribe to the channel. Because if these images truly reflect what the data indicate, we are looking at a body accelerating through the solar system without ejecting absolutely anything. And that raises an uncomfortable hypothesis. Perhaps 3I Atlas is not a comet. The first signs that something was wrong emerged in late October. As the object approached perihelion, the expected behavior would have been gradual deceleration. Instead, it accelerated. Data associated with NASA Jet Propulsion Laboratory showed that Atlas deviated from its predicted orbit by about 4 arcseconds. At that distance, approximately 126 million miles. This corresponds to a displacement of tens of thousands of miles. Something was altering its trajectory. Calculations revealed an acceleration away from the Sun of about 0.2 millimeters per second squared, accompanied by a nearly equivalent lateral drift. In just 1 month, that amounts to a displacement exceeding 50 miles, far too large to be explained by random fluctuations or measurement errors. The question echoed through observatories around the world: what was pushing 3I Atlas? The traditional explanation would be gas release. But to generate that thrust, the object would have to expel roughly 1/6 of its total mass, around 5 billion tons of vaporized material. That would create a bright coma, impossible to ignore. And yet, the sky remained empty. No cloud, no tail, no vapor. In space, icy objects react to heat. They change. They transform. 3I Atlas did not change. It remained compact, silent, and apparently immune to the sun. The central question remains: are we facing an extremely rare natural phenomenon, or something that simply does not behave like anything we have ever observed? Because if there is no gas, there is no jet. If there is no jet, there is no natural engine. And if there is no natural engine, then what is moving 3I Atlas? Nothing. To understand how absurd that is, the Virtual Telescope Project released a side-by-side comparison between 3I Atlas and Comet C2012 F6 Lemon, a completely ordinary comet photographed under identical conditions just days earlier. Lemon behaved as expected, with a radiant, ghostly tail flowing away from the sun, perfectly shaped by solar radiation. But Atlas? It remained just a point, sharp, compact, intact. It was like comparing a living organism to a statue, one radiating motion and energy, the other frozen and silent. Watching Atlas accelerate without producing debris is like watching a rocket fly without exhaust. Physics does not merely fail, it collapses. When Loeb recalculated the numbers, he discovered that if the acceleration were truly cometary, the expelled gases would have created a glow brighter than the full moon. And yet, the images from November 5th show none of that. The object's magnitude, color, and symmetry remain disturbingly constant. The director of the Virtual Telescope, Gianluca Massi, called it the most baffling observation I have ever made. Because even instruments designed to detect the faintest traces of dust returned the same reading, 0. When the data reached Harvard, Loeb and his team began reconstructing the physics behind the acceleration. Using Atlas's estimated mass, 33 billion tons, nearly 1 million times heavier than Oumuamua, they concluded that no known natural process could account for the force acting upon it. Solar radiation pressure was far too weak. Gas release was invisible. Gravitational interactions with planets were impossible at that distance. One option remained: an unknown mechanism. "We must accept what the data are showing us," Loeb said. "If physics fails, theory must adapt." But few were ready to adapt to the implications. The truth was too heavy, because the numbers did not merely describe motion. They described intention. The acceleration was not random. It was smooth, consistent, perfectly aligned with the sun's position, as if someone, or something, had calibrated it. The last time we saw remotely similar behavior was with Oumuamua, but this time the effect was stronger, faster, and far more deliberate. As data from telescopes worldwide were analyzed, a pattern began to emerge. 3I Atlas was not just breaking one rule, it was breaking all of them. Its orbit was almost perfectly aligned with the ecliptic plane, within 5 degrees of the path followed by Earth and the other planets, a coincidence so improbable that Loeb compared it to hitting a cosmic target in total darkness. Then came the jet anomaly, an ejection of material launched directly toward the sun, the opposite of what any comet does. Normally, solar radiation pushes dust away from the sun, forming tails that always point outward. But Atlas defied even that, as if repelling sunlight itself. Its speed was another impossibility, faster than smaller, lighter bodies like Oumuamua and Borisov, even though its mass should have made it slow. And its brightness curve defied logic. As it approached the sun, its luminosity increased at a negative magnitude rate of 7, twice the intensity of any known comet. Then came the color, blue. Not icy white, not glowing red, but an electric spectral blue, hotter than the sun's own photosphere. Its surface temperature appeared to exceed 5,800 Kelvin, something no natural object can achieve without vaporizing. At that point, astronomers were not just confused, they were alarmed. Because if 3I Atlas is not following the rules of celestial mechanics, then it is following something else, perhaps a command. Spectroscopic analyses from the James Webb Space Telescope and ground-based observatories revealed something even stranger: the object's composition. Unlike natural comets, which contain random mixtures of rock, ice, and minerals, Atlas displayed a precise nickel-to-iron ratio, the same found in high-temperature alloys used in spacecraft and jet engines. In nature, metals mix chaotically, but in Atlas, they were balanced, refined, and organized. It also contained only 4% water, drier than the most arid deserts on Earth. Not the dirty snowball we expect, but a structure that appears forged, not frozen. Some scientists now suspect the outer layer may not be natural at all. It could be a ceramic or composite shell, heat-resistant and polished, which would explain why it reflects light so cleanly, without cracks or irregularities. That reflection produces an unprecedented polarization signature, light waves aligned with mathematical precision, something never observed in a natural body. As Loeb stated, if you were designing a probe to survive a billion-year journey through the galaxy, it would look exactly like this. And then came the revelation that shocked even the skeptics. When researchers traced the trajectory of 3I Atlas, they realized that its path crossed the orbits of Mars, Venus, and Jupiter, but not Earth's. The timing was perfect. During perihelion, when it should have been closest to Earth and easiest to observe, it positioned itself behind the Sun, hidden from our instruments. This alignment is statistically so improbable that some astrophysicists believe it cannot be coincidence. "This isn't random," said an analyst at NASA Jet Propulsion Laboratory. "It's deliberate navigation." The idea sounds insane until you look at the calculations. The orbit is so precise that when projected backward in time, it points directly to the same region of the sky from which the WOW signal originated in 1977, a narrowband radio pulse that SETI Institute has pursued for decades. Two phenomena, separated by decades, coming from the same cosmic coordinates. Coincidence? Perhaps. But as the data accumulated, perhaps began to sound like denial. Each new image released by the Virtual Telescope project only deepened the mystery. The color of 3I Atlas, a deep ultraviolet blue that no comet should emit, defied all thermal models. Blue light means temperature. Blue light means energy. And yet the object showed no signs of deterioration, fragmentation, or infrared thermal signature. It shone with a light that was not heat, a light that seemed self-generated, like plasma radiation or ionized gases under control. Some plasma physicists propose that the object could be using electromagnetic propulsion, generating thrust by manipulating the solar wind itself, a technology humans have only tested at an experimental level. Others believe it may be something simpler, the remnant of a machine so ancient and autonomous that it continues operating by instinct long after its creators have vanished. If that is true, perhaps we are not merely observing alien technology. Perhaps we are witnessing alien persistence, a mechanism still fulfilling its mission after ages of silence. And so, the countdown begins. On December 19, 2025, 3I Atlas will make its closest approach to Earth, passing at a distance of approximately 167 million miles. Close enough for every major telescope, from Hubble to Webb, to capture it with unprecedented detail. If it is a comet, we will finally see the gigantic cloud of gas that physics demands. But if no cloud appears, if Atlas remains the same silent, blue, perfectly compact body it has always been, then the entire cometary explanation collapses. What will remain is something far more disturbing. Could it be a probe, an autonomous observer, scanning our solar system as part of an ancient experiment? Or something even stranger, a device designed to activate when civilizations like ours reach the nuclear threshold, as some speculative physicists now fear? For now, no one knows. But every image, every spectral line, every silent movement in the darkness suggests one thing. This object is observing, and it may not be finished yet. As the latest images from the Virtual Telescope project circulate through laboratories, observatories, and online forums around the world, a feeling hangs in the air heavier than fascination itself: unease. The cosmos has just delivered another impossible enigma, and this time, it is staring back at us. 3I Atlas continues its journey through the solar system, cold, blue, and silent, defying every equation we have ever trusted. It does not behave like a comet. It does not resemble an asteroid. It does not fit into any of the orderly categories human science has built to understand the sky. It accelerates when it should decelerate. It glows blue when it should shine white. It hides when it should blaze. It follows a trajectory that feels less like coincidence and more like choreography. And yet, when the data arrive, they arrive with absolute clarity, no noise, no error, as if the universe itself were forcing us to see something we have spent centuries trying not to notice. The more we learn, the less we understand. Each new image released by the Virtual Telescope project deepens the paradox. The same compact, luminous point of light perfectly stable, perfectly calm, perfectly alien in its indifference. It is as if the sun itself cannot touch it, as if radiation, gravity, and heat slide off its surface like light reflected from a mirror. If it is natural, then it is rewriting our definition of what natural truly means. If it is artificial, then we have just witnessed the most profound discovery in human history, the evidence that we were not the first to walk beneath these stars. Either way, the world we thought we understood has already changed, because the question is no longer whether this object is a comet. That question died the moment it accelerated without a tail. The real question, the one no one dares to speak aloud, is this: what kind of intelligence designs something capable of traveling for billions of years through interstellar space, powered by something we cannot detect, guided by a precision we cannot explain, and still functioning perfectly after eons? What kind of civilization does that? How long ago did they live? Are they still out there? Or are we observing the drifting relic of their memory, a ghost ship crossing the cosmic ocean, repeating its mission long after its creators have turned to dust? Dr. Avi Loeb warned us years ago that when science refuses to confront anomalies, it turns into dogma. We cannot claim to seek truth, he said, if we only accept the truths that make us comfortable. 3i Atlas is that discomfort, a reminder that the universe is not obligated to fit within our theories. It never was. The sun does not ask our permission to burn. The stars do not need our approval to shine. And when something enters our skies that we cannot explain, we must question it, not dismiss it. Here we are again, facing another visitor from the darkness, and the silence surrounding it feels almost intentional. Perhaps this is how first contact truly happens, not through radio signals or blinking lights in the sky, but through subtle disobedience to expectation, through silent impossibilities that force us to look again, to think differently, to evolve. Perhaps that is the lesson of 3i Atlas. That discovery is not about conquering the unknown, but learning to stand before it without fear. And now, as December 19th approaches, the day it will pass closest to our planet, every telescope on Earth will be turned toward it. Perhaps we will finally see what it truly is. Perhaps we will see absolutely nothing. But whatever happens, we will remember this moment. The first time in human history that a fragment of the cosmos seemed to look back at us and refuse to explain itself. Because sometimes the universe does not whisper its secrets. Sometimes it places them before you, in plain sight, and dares you to believe. If this story made you question what truly exists out there, don't let it disappear into the noise. Subscribe to this channel because we will continue following 3i Atlas until its light fades beyond our reach. Turn on notifications. The moment new data emerges, you will be the first to know. And tell us in the comments, what do you think 3i Atlas really is? A rock? A probe? Or the first message from a civilization that learned how to speak in silence?